Hi everyone, welcome to this video series on word embeddings used in natural language processing. In this particular video, we will talk about how we can extend the concept of word2vec to something like representing a document or sentence or paragraph or entire PDF, so on and so forth. Let's get started. So essentially, we have gone through almost all the units or subtopics, starting with the idea of embedding, the background behind embedding, intuitions, and how we generate the training samples or training pair for training the word2vec algorithm. We also saw what is embedding layer, how we use embedding layer in Keras and TensorFlow. With some dummy data, we generated word2vecs and some example use cases with Gensim. And we also saw text classification example using Gensim. Optimization, very important topic, hierarchical softmax and negative sampling. These were the two methods that we covered as part of the optimization video. Now, in this particular video, we'll talk about the extensions, how we can extend the same concept of word2vec for something like document representation or sentence recommendation representation. Finally, we will also talk about the shortcomings of word2vec model. So let's talk about the extensions of word2vec. Essentially, word2vec can be transformed or aggregated to represent sentences, paragraph, or documents. So document embeddings represent the entire document. For example, one paragraph of 10 sentences. Then the vector representation for all the 10 sentences in the paragraph would be the representation that we are talking about. So techniques like document to vec and paragraph to vec or sentence to vec are commonly used in this context. So essentially, document to vec or paragraph to vec will capture the representation or the meaning of that particular unit, let's say sentence or paragraph or the entire PDF. So the document to vec is an extension of word to vec model specifically designed for document level embeddings. Now, as we remember, the word2vec is actually continuous or dense vector representation of each of the word. So document2vec extends this idea to learn vector representation for entire document. It could be sentences, could be paragraph, it could be the page, or it could be entire document as well. Now, one of the simplest technique that we can use here would be, for example, let's say we have, word one, word two, and word three, and word n, and that represents your sentence. So if we know the word vectors for each of the word, we can add them together, and that will represent the vector or that will represent the sentence. That's one of the simplest way that can be done as well. But that's not what we are discussing here. Mikolov and team suggested slightly better approach than simple aggregation in this paper, distributed representation for sentences in published in 2014. So there are two different architectures to achieve the document to vec or paragraph to vec or sentence to vec. So first one is called distributed memory. In this case, a unique vector representation is learned for the paragraph or the document as well as for each word in the corpus. So it's going to combine the document vector with the context word to predict the target. I'm going to explain this particular paragraph with a diagram. And you could also do with the continuous bag of word exactly the same formulation. In both of these architectures, we use a separate vector for the paragraph or for the sentence here. So I'm going to take one example here to illustrate how it's going to look like in terms of architecture and in terms of training. So here is the word here, the word vectors. Let's say V stands for vocabulary and you have 10,000 words and you're going to have word representation randomly initialized first. And similarly, we would have a document vector as well, and that one is also randomly initialized. What we're going to do is we are going to concatenate these two vectors. The one would be the vector for the word and then the vector for the document or paragraph. So we're going to add them together, concatenate, and that's what is going to be fed to the neural net or the hidden layer. And finally, as usual, that we have done in the Word2Vec, we will do a softmax function and we will predict the target word. And essentially after that, the backpropagation and gradient adjustments would be done to the parameters on the input side. And with number of trainings, the vectors would be learned for the word and also the document. This is in essence is your document to vec model in Gensim. Let's take a couple of example or simple example to understand this. Here we have a small corpus of two sentences, quick brown fox, blah, 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 and lazy dog sleeps peacefully in the sun. This is the, corpus that we have. And we are talking about distributed memory architecture. The first step, we will tokenize. Sentence 1, tokenized. Sentence 2, also tokenized. After the tokenization, we are going to assign vectors to each of the word. Initially, it will be randomly done. And then we will assign the vector for the document as well. So initially, it will be randomly initialized. And let's make an assumption that we are going to initialize the vector with three-dimensional, real numbers. So the word like the, quick, and similar other words would be represented using three-dimension vector. And likewise, we would do for the entire document as well. So so here the document that we're talking about is the sentence. Each of the sentence becomes a document. So we're going to randomly initialize the vector for each of these sentences here. Now in the training process, what we do here is for each context and the target pair that we saw in the Word2Vec, traditional Word2Vec. So we will choose a context and target pair, and the target is a specific word in the window itself. For example, the quick brown fox could be the context and the target may be jumps. So that means the context word, the quick brown fox, needs to predict the word jumps. Now what we're going to do, we'll combine the context and the document vector that we randomly initialize in the previous step. So in this architecture, we will combine the document vector with the context word, both the context word and the document vector will now be participating in the model to predict the target word. So let's take an example here. The context is the quick brown fox from sentence 1, and model will use the document vector for sentence 1 along with the quick brown fox from the sentence 1. These two guys will be used as predictors to predict the target word called jumps. This is a slight adjustment to a typical Word2Vec architecture that we discussed already. So this is the training process. Now the prediction, or the back propagation and a forward propagation, essentially results in the similar error calculation. The model is going to predict the probability distribution of the target word given two things. So first one is the context vector, and the second one is a document vector. Based on this, we will make a prediction, and that prediction will be compared with the actual outcome, and the difference is going to be used as derivative, and then we update the weights. So in this case, weights are nothing but the embeddings. After that, we update the vectors, which is basically the weights in this case. And we will repeat this process for as many iterations that we have set. So the process is repeated multiple context target pairs across the corpus, and the goal is to learn the representation for both the words and also the the document. In this case, the document is the sentence level. So I'm going to show you some Python code here to illustrate how Document2Vec is actually used. So let's look at a very simple vanilla example of a Document2Vec in Gensim. And as I described earlier, you have additional vector representation as the input to the neural net, and the output layer is going to give you the softmax probabilities for each of the vocabulary word. So nothing changes in terms of the output here. Gensim has a library called Document2Vec, and we import that particular function, and then Gensim requires the input, which is a sentence here in a particular format. For that, Gensim is providing one more function or library here. So we are going to run this, and let's say this is what we have, and we have the document 1, document 2, 3, 4, 5, and so on and so forth. What we do is a tagged document, and we pass the input data, which is in your documents variable. This tagged function will actually prepare the data in terms of a list. For example, this is the first sentence or a first document. This is the second one, third one, so on and so forth. So we are using Gensim's tagged document function to prepare our data. So this has to be in this format. You can do it in manually, or you can use your own function as well to do it. Essentially, you need to give a name to each of the document tag 1, 2, 3, 4, and so on and so forth. Now the setting that Document2Vec has, DM1, means it's going to use distributed memory architecture. If you set it to 0, then it's going to use the other form of the Document2Vec. So we're going to use the DM equals to 1. Vector size 50, that means the dimension of the sentence vector would be 50 dimension. Window is similarly, you can use 2, 3, 4, or 5, depending on the need. Minimum count is, in this case, is a small data. So I just use one. That means if the word is appearing, consider it. And then dm equals to 1. That means that particular architecture. So this is the architecture that we are talking about. Now set up the Document2Vec, build the vocabulary using the tagged data, and then after that, you train it. So after the training is done, now the model has learned from the input data and the vector representations for the word and also for the document or sentences. Now, if you have a test data, you can make use of the test data here to infer for that particular document the vector representation. So this is the vector representation for your test data. And after that, you can use that for any kind of analytical work or text classification and so on and so forth. In my next example, I'm going to show you how to use the Document2Vec for text classification. In this series, we have been talking about IMDb so far, movie reviews and a positive, negative sentiment analysis and so on and so forth. So same data set I'm going to be using. The data set is huge. So in this case, I'm not going to be running these cells, but I'll show you the outcome. So as usual, you have Document2Vec here and tagged document. And we will have, let's say, for example, logistic regression as a classifier finally to do the machine learning for us. So this is my input data. So read the data, and I'm going to focus on the last column called cleaned text. And this is what is going to be used to train the Document2Vec. So let's pick up that particular column, and then we convert the positive, negative to 1 and 0. You may want to do stop word removal or stemming, lemmatization, and all kinds of pre-processing step that you feel is required. Then we do a train test split, and using the training samples, we will be training the Document2Vec model. So first, create the tag document out of the training sample, and there are 40,000 samples here. Configure your Document2Vec, choose the dimension of the vector representation. Window size, again, a choice that we need to make. And minimum count, you can choose 2, 3, 4, depending on number of iterations, very small number of iteration. So now this is what you have configured the model. Build the vocabulary, that step is required. And then we train the Document2Vec model here. It's going to take about a minute or two in this case. Now we can infer the vectors for the training samples and the vectors for the testing sample. Use logistic regression, and the vectors that we inferred would be the input to the logistic regression, and then train the logistic regression with the vectors that we inferred in the previous step. And then we can use the test vectors to predict. And as usual, you can do the accuracy score, classification report, and this is not bad. You can see we are getting a accuracy score of 83 with just a very simple model here. You can also test out if the vectors are getting overfitted using cross-validate function of sklearn. Provide your training vectors and set up the k-fold, let's say stratified k-fold. And the result is the training accuracy 84, test accuracy 84 means it is not overfitting case. It's pretty okay. There's still significant room for experimentation in terms of choice of dimensionality, the choice of number of iterations, and learning rate, and so on and so forth. This is how we can use document representation for a typical NLP task like text classification. I hope you liked this particular illustration, coding example. The code sample will be attached in the description below. Now, finally, we'll just talk about some of the shortcomings or weaknesses of Word2Vec model. So I can, talk about the next series of word embeddings like fast text and Almo and BERT and transformers and so on and so forth. Let's look at some of the shortcomings of Word2Vec. Lack of interpretability. Now, this lack of interpretability is not exclusive to Word2Vec. It is for any kind of embedding that we are talking about in deep learning. So the vectors generated by Word2Vec or Document2Vec, they lack, explainability. It's very hard to explain from the, set of numbers as to what they mean. So some of the solutions that we can actually use to, address this problem, try doing visualization of the embeddings using, dimensionality reduction techniques like PCA or TSNE and observe the relationship among the tokens or, chosen tokens. Examine for nearest neighbors of specific token. That could be another approach. Conduct some word analogies, experiments, and exercises, like if king is to a man, then what is to a woman? The result should come queen. So likewise, we should actually experiment with hundreds of analogies to make sure the embeddings make sense or embeddings are useful. Finally, trust a pre-trained embedding model rather than building your own. Other shortcoming is the contextual information. Word2Vec creates a fixed embedding for just looking at the word. It doesn't matter in which context the word is being used. It generates the same representation regardless of the context that the word is being used. So the solution is to look for advanced embeddings like BERT and GPT, and I will be talking about these embeddings in the subsequent videos. Cold start problem is a major problem in Word2Vec and Document2Vec, not so much in Document2Vec, but in Word2Vec for sure. The reason is if a particular word is not known to the Word2Vec model when it was trained, then it will give you an error at the time of usage or predictions. This is called cold start problem. That means if you have new tokens in your data, you will have to retrain your Word2Vec model. Lack of subword information is another limitation with Word2Vec. It does not consider subword information. So the solution is to look for a later version of Word2Vec, popularly known as fast text. And I'll be having a separate video just after this on fast text. Some other issues with Word2Vec, polysemy and homonymity. It's not able to disambiguate between the words with multiple meanings or distinguish between the different words which are spelled the same. That means the contextual intelligence is not something that we can achieve with Word2Vec. For example, if you use the word bank It may be a financial institution, or bank could be a side of a river. Word2Vec has no ability to distinguish between the two. And that's why we will be talking about advanced embedding techniques by transformers and the BERT and fast text and Elmo, for example. It's limited to the word level representation. That is another limitation of Word2Vec. It cannot do piecewise or subword wise. It's only limited to a word. That means it doesn't know um, anything about phrases or bigrams or trigrams. So those are limitations of Word2Vec model. Word2Vec model also does not consider word order that we know uh, by now. It just uses a sliding window concept and generates the training pair or context and the target pair from the window. So it does not consider the positional sense or the position where the word is being used in a sentence. So these are the limitations of typical Word2Vec. Thank you all for listening to me, and we will see you in the next video.